Okay, we're on number 7 here in chapter 3, lesson 2. Imagine a point that moves across a coordinate graph so that its y-coordinate is always 3 more than its x-coordinate, okay? So now, I know you're thinking of a moving point, okay, and that could be a little misleading the way he says it. Uh, I would like to refer more to it to the graph, okay, of the function, that it moves across the coordinate graph. So you think of that line, or you can just bounce from point to point, okay? And when you look at a point, and you'll notice that its y-coordinate is always 3 more than its x-coordinate. Okay, now think about that. Something is 3 more. Let's say you have a sibling who's younger than you, and you might be 3 years older, so you have 3 more years. So if your sibling was, let's say, 9, you might be 12, or if your sibling was 10, you might be 13. And we can put in any number, so that's 3 more, okay? And of course, it could be the other way around. You can have a sibling that's 3 years older than you, so they are 3 more. So, and again, I'm just trying to use the words. I'm trying to have you understand that if you were to try to figure out the age of either your sibling or yourself, depending upon who has 3 more, you would be adding 3. So, let's follow the first one here. It says, copy and complete this table of some of the points positions. Now we see that the x and the y table has been set up with 0 and 3, and then we have the following 1 to 4. So 1, 2, 3, and 4. And we were told that it would be 3 more. The y is always 3 more. So if we were to fill in the rest, we'd say, well, 3 more of 1 would be 4, and 3 more of 2 would be 5, and 3 more of 3 would be 6, and 3 more of 4 would be 7. So here we now have a complete table. All right, and we were told to copy and complete the table just based on what we already knew. They told us that it was always 3 more. We can't assume it just from the first one, but we applied it, and this is what it would look like. Okay, they told us that it was always 3 more. Now, we're to write a formula. Now, what do we know about this formula? Well, if you remember, we used a particular form. It was y is equal to ax plus b. Ah, the plus and the b. Well, what's the constant here? Well, the constant here is b being added, 3 being added, which is b. All right. And what's happening? Well, we don't really have an a constant here, do we? We we were simply just multiplying by 1, okay? Because we're just adding. We're not changing x. So we could write 1x, or we could just simply say x plus 3, right? Because we're not told to change that the x value is going to change. We're not multiplying. We wouldn't say, for instance, 2 times the x value plus 3. Well, in that case, that would be 2x plus 3. But we're just simply told that the x value, we're just adding 3. So the a kind of goes away, and you say, well, how is this in the same form? Well, technically, there's a 1 hidden in there, okay? But we don't need to see it. It just confuses us a little. So let's get rid of the 1. And we have y is equal to x plus 3. All right, now what we're told in C is to plot the points and join them with a line and extend it into the second and third quadrants, okay? So if we're going to do that, we're going to need our black marker. We're told to plot the points. Okay, so the first point up here is 0, 3, so we don't move on the x-axis, but we move positive 3. So 1, 2, 3, so our first point goes right there. And what's our second point? Well, we go over 1x, and the y value is 4, so there's 1, 4, then 2 across, 5 up, then 3 across, positive 3, up to 6, and we see it's forming a nice little line there, and then 4 and 7, okay? So what we have here, remember this? This would be a linear graph, right? We did a direct variation before, but this is a linear graph. It does not intersect at the origin, but it is a straight line. But now we're told to extend this or to extend it into the second and third quadrants. Well, let's remember that this is the first quadrant. So we're in the first quadrant, but we're not told necessarily to focus on that. We're told to extend it into the second and into the third quadrant. So we're going to need, and I should always put my little line underneath these. Otherwise it looks like 2ND and 3RD, so it's third, and this is the fourth. And you can write these in the beginning until you get used to it. I think you'll get used to them fairly quickly. Now we're going to draw a line. And we want to extend that line as we're connecting, and we would be connecting here. But we're extending it, and as we keep the line straight, we can't do this, okay? Got to connect all the dots. And now we're extending into the second quadrant and now into the third. So how far you extend is up to you, but I would say that this is pretty close right there. You could probably draw a better graph than I draw, but that's now into the second and into the third quadrant. And then lastly, we're told to copy and complete this table of some other positions of the point by referring to your graph. Well, we would refer to the graph. They're telling, don't go to the equation yet. Now you might say, well, Mr. Cartagena, you told us not to really refer to the graph. Well, one of the things I can say is that this graph is very friendly. As we can see, it's always intersecting at a whole number. Okay, so when we're looking at the whole numbers, it's always intersecting. So when we look at a whole number, for instance, -3, okay, it's at 0, and -4 is at -1, and -5 is at -2. Okay, so we did -4 is -1. We see that. What would -3 be? Well, -3 would be 0, so we'd write 0 there as a y coordinate. How about -2? -2 would be -1, and -1 would be -2. Oh, excuse me, I'm using the negatives incorrectly. Let's go back. -3 will be 0. -2 will be +1, okay, because we're in the second quadrant. We went up, okay, so, and then let's go back. And that's very common. Sometimes we rush through and we're just saying, okay, I went negative and I guess the other one's negative. Well, no. Sometimes it's negative and it goes positive. Sometimes it's negative and it goes negative, but it would be in a different quadrant. So imagine you're looking for your car and I told you to go to -3, -1, okay, or let's say -2, -1, well, you'd be looking for your car here, and you wouldn't be anywhere near your car because it's over here. So we've followed the instructions, and we've completed the table by referring to the points of the graph. Now, if you look at your formula, you can always double check your work by looking at your formula and putting those numbers in, and you're going to realize that these numbers are the numbers that we found on the graph.